All right, let's jump right in. We're going to tackle something huge today, building an entire EV charging network from the ground up. But the interesting part isn't the physical chargers. It's the invisible blueprint, this kind of unsung hero in the code that actually makes the whole thing work. Let's do it.
Okay, so let's frame the problem, right? You're in charge of this massive network. You've got chargers from all these different companies. Some are fast, some are slow, some take credit cards, some don't. How do you possibly build one single system to control all of that chaos without just going completely insane?
I mean, it sounds like a total nightmare, doesn't it? Just this tangled mess of custom code for every single model you add. But what if there was a better way? What if I told you there's an incredibly elegant solution that lets all these different devices speak the exact same language?
And that brings us to the hero of our story today, the programming interface. Now, I want you to think about this not just as code, but as a contract. It's this powerful unifying agreement that's going to bring order to all that chaos we were just talking about. Okay, this is the absolute key idea. An interface, it's just a promise. It's a contract that says, hey, if you sign on this dotted line, you must be able to do this specific thing. The system doesn't care how you do it. You could use magic, you could use tiny robots. It doesn't matter. It only cares that you can do it. It's all about the what, not the how.
So what's really cool about this is how you can take a super complex thing, like an EV charger, and just break it down into its basic jobs. You create a separate contract for each capability. You'll often see programmers name these with a little I in front for interface. So if a device can charge a car, boom, it signs the iCharger contract. If it can take your money, it signs the iPayment capable one. It's a really simple, clean way to just list out what a thing can do.
Okay, so now let's see how this whole contract thing lets us build a ridiculously flexible system. The analogy is perfect. It's like you've written up a bunch of job descriptions, and now you can hire all sorts of different workers as long as they're qualified for that specific job. And this is where the magic really happens. Look at this. We've got a standard AC charger and a super fast DC charger. They've both signed the same iCharger contract. That contract says they must have a way to start a charging session. But look how they do it. They fulfill that promise in completely different ways. The AC one starts a standard charge, but the DC one, it boosts it with a ton of power. See? Same contract, totally different way of getting the job done.
And here's the real kicker. Your main system, it has no idea if it's talking to a slow AC charger or a fast DC one. It doesn't care. All it knows is, I'm talking to something that signed the iCharger contract. This means you can literally unplug one and plug in the other, and you don't have to change a single line of code in your central software. Think about what that means for a business. You can add brand new charger models from any company without these huge, expensive software projects. That is a massive game changer.
Okay, so that works for simple chargers. But what about the fancy ones? You know, the top-of-the-line model that can do everything. Charge super fast, take payments, run its own diagnostics, even update its own software. How do we handle a multi-talented superstar like that?
Well, it's actually super simple. It just signs more contracts. You can think of this premium charger's list of interfaces as its resume. It clearly lists out all its skills. Our system can just glance at it and know, yep, this one can charge, it can handle payments, it can do diagnostics, all of it. It's like you're building a device out of a menu of different capabilities.
All right, so this is all working beautifully. But what happens when our network scales up? I'm talking thousands, maybe even millions of chargers. We're going to need some ground rules to keep our contracts clean. Otherwise, we're just creating a whole new kind of mess.
And this right here shows a classic trap people fall into. You might be tempted to just create one giant, what we call a God interface, that has every possible feature baked into it. But what's the problem with that? Well, what about a cheap basic charger that can't take payments? It's now being forced to sign a contract for a job it literally can't do. That's why we keep our contracts small and focused on one thing. It's a principle called interface segregation, and it basically just means that a device should only have to promise what it can actually deliver.
But that raises a really interesting question. What happens when things get a little more complicated? Let's say our system evolves, and we have two different contracts that happen to use the exact same term. Maybe we have an iAudit contract and an iDebug contract, and they both need a method called log. How in the world does the charger know which log it's supposed to use for which contract?
The solution is actually pretty elegant. It's called explicit implementation. Instead of having one generic log function and causing confusion, the charger's code gets really specific. It basically says, okay, when the iAudit contract asks me to log, I'm going to use this version. And when the iDebug contract asks me to log, I'll use that one. It's like having two different tools with the same name, but you know exactly which one to grab for which job. All the confusion is gone.
Okay, so we've laid all the groundwork. We have our contracts, we have our different workers that can fulfill those contracts. Now it's time for the payoff. Let's see how the brain of the operation, the nerve center of our network, puts all of this together.
So meet the charging session controller. This is the manager that oversees a single charging session. And here's the most important thing to understand about this manager. It is completely clueless about the specific brand or model of charger it's dealing with. It doesn't know and it doesn't care. All it knows is how to speak the language of contracts.
And check out its logic. It's so beautifully simple. First, it just asks the charger, hey, do you happen to be iPayment capable? If the charger says yes, great. It processes the payment. Then it uses the iCharger contract, which it knows every single charger has to have to kick off the session. Finally, it might ask, by the way, do you have iDiagnostics? If so, it'll grab a health report. It's just checking for skills and using them if they're there. And that brings us to the most important number of this entire explainer, 0. That's the number of times you need to change the code for the charging session controller when some new futuristic charger model hits the market, 0. For the business running this thing, that number translates to one thing, speed. It means they can bring on a new hardware partner and get their chargers plugged into the network in a matter of days, not months. That's a huge competitive advantage.
All right, we've covered a ton of ground here. So let's do a quick recap of the big ideas that make this whole system so powerful. Think of this as your cheat sheet for making interfaces the star of the show.
So here's the playbook. First, remember an interface is a contract. It's the what, not the how. This is what gives you those awesome interchangeable parts. Next, a single device can sign multiple contracts to show off all its different skills. Always remember to keep those contracts small and focused, no God interfaces. And if you ever have a name clash, just be explicit about which contract you're fulfilling. That's it. That's the core set of rules that lets you build systems that can truly evolve. The whole magic that makes it work is this idea of polymorphism. And I want to leave you with this really powerful idea from the source material. A class isn't a charger just because we call it that. No, it becomes a charger by implementing the iCharger interface. It earns that title by signing the contract. It's a complete shift in how you think about building things.
So that leaves us with a final question for you. Think about the projects you work on. What are the contracts that are holding them together, even if they're not explicitly written down? What are the core capabilities? And could making those contracts the protagonists of your design make everything you build just that much more flexible, scalable, and powerful? Something to think about. Thanks so much for joining me.